Hello everyone, this is Naman, and in this video I'll be showing you all a demonstration of how to set up and operate a FQ2 Omron Vision Inspection camera using a software called touchfinder. Alright, so once we are online, the first thing we need to do is we need to register the standard model to the camera processor. So we'll click camera setup, we'll take an image, and as you can see, the brightness over here is, you can see that the camera is trying to autofocus and it's trying to adjust the range and the brightness. So yeah, this is one of the very interesting features of the camera, and there are other things as well. You can rotate the image if you want to. You can rotate the image. Yeah, and you can. We'll keep it like this, and once we'll take an image again, and then we will click back. You can also change the contrast, brightness, and other functions. So the next thing we need to do is we need to set up the measurement functions so that the other parts can be inspected based on that particular model of measuring function. So the first one, alright, so I'll first show you guys how to use color data. So yeah, so this is the inspection region. We'll set the inspection region. Alright, so the color data compares the difference in color between the workpiece and a registered image. So we click OK, and then we click Teach. And once it is registered, we click back again, and then we can add, let's say I'll go with Shape Search 3. So the advantage of Shape Search 3 is multiple objects within the inspected parts can be identified without being affected by light interference or background changes. So it's a very accurate feature which is provided by Omron for inspection of a part. You might be wondering why I selected Shape Search 3 instead of Shape Search 2. So the thing is, Shape Search 3 is the latest version of the Shape Search feature, and it is almost 10 times more accurate and precise than Shape Search 2. And I'm not making up that number. It's there in the Omron manual for the camera that it is a much efficient version. So once you have all these demarcations, you can either enhance the edges, but I think it's clearly demarcated all the parts. So you can do that. You can add some noise if you want to. You can change the noise level. We don't need that now, so we'll keep it like that. Then we'll click OK. And then we click back, and then we click Teach. And once this image is registered, we click back again, and it is saved. Back again. And now we need to see if the data which we have captured is stable, and yeah, it is. We are good to go. Judgment is okay. Click back, and now we will switch from adjust mode to run mode, and all the data will be saved automatically. Alright, so now we have our model set. So what we will do is we will look at several inspection items. So we will just capture some random images. So right now there is nothing in here, so it's showing that it is non-conforming. And let's see the calculations for it. Alright, so there is zero correlation. It shows that the part with the image which has been captured has zero correlation with the part which is the reference model, the correct part which is registered to the camera. And the color difference is 188, which is very high. Yeah, and let's see if we put this thing back again over here, what happens. Alright, so the color difference is almost 0. And let's look at the shape search result. So it is almost showing that it is correct, and it's almost 93% conforming. Let's see what will happen now when we flip this car over. Let's see if this thing is conforming or not. So what we can also do is we can change the alpha levels. So we can keep the alpha level to, let's say, 90 for this model. So we keep an alpha of 90. I mean, not the alpha. The alpha is 10%. So the CI can be 90. So we click OK. And now you can see that it's showing that it is non-conforming. So it's showing that it is 72%. There's only 72% correlation. So it is no good. So let's see if we remove one of these components and whether it shows it is non-conforming or not. So I've removed one of the parts, smaller parts from the camera, and if it gives the correct result, yeah, it is showing that there is a difference. Yep, and alright, so my bad. I reversed the image. Alright, so even now it is showing that there is like 14% alpha, which is beyond the 10% alpha that we have. So I mean, what I actually did was I removed this part over here. You can see I'll replace this part back again. Alright, so now you can see we are back to the correct result. Alright, so let's see if I put my hand over here and I take an image. It is showing a correlation of 0. So guys, this camera is pretty amazing. I mean, it can detect any wrong part within a flash of a second. So the guys who will be actually monitoring the quality, it will be a very useful tool for you guys. So, yeah, this is just a basic demonstration. We could have created a much more accurate model, but since it is just for demonstration purposes, I am just giving you a rough idea of how this thing works. So